Greetings for the day, friends. I would like to give you an overview about plastic, mainly giving you an overview about thermoset. First, I will brief you what are all the different type of plastics we have in the current world. This is mostly to give a brief overview about for the beginners. What does the plastic mean? So, plastics are mainly classified into three categories. One is thermoset plastic, thermoplastic, and elastomers. So, let us look at them, what each one of them mean to us. I will give you a brief overview about each of them, what they mean. So, let us begin with the last one, elastomer. Elastomers are characterized by a wide meshed cross-linking of the knots, like one you see in the explanation of chemical formulas. They draw different ingredients sketches. So elastomers are basically, in general terms, you can call them as rubber. They are a chain of molecular linkages which creates the material, and this kind of a cross linking creates those materials, and they have a high level of dimensional stability, but still they are elastic, malleable. When you apply a load on them, they get squeezed or they change their shapes, but when you take out the load, they come back to the original shape. So they have that elastic property, and we widely know them as rubbers, and we use a lot of rubber parts, be it in home environment, be it in our automobiles or any other white goods. So all the areas we use rubber. And the second one is thermoplastic. I think when it comes to thermoplastic, we know thermoplastic very widely. We use them, we touch them on a day-to-day basis. So thermoplastic polymers are a plastic in which, unlike elastomer and thermoset plastic, so you will hear what is thermoset later, the molecular chains are not cross-linked. They consequently demonstrate a plastic elastic behavior and formable. That means when you melt them, they get melt, and when it cools down, they get solidified, and you can repeat these process of melting them and cooling them, and they take the shape of the mold or the cavity what we have provided during the process of cooling. So most of us, we know that injection molded plastic parts or blow molded plastic parts, roto molded plastic parts, these are mostly the material used in those processes are mostly thermoplastic. So I will give you one more very normal home-based example after I explain you a bit about thermoplastic and thermoset plastic. So let us look at what is thermoplastic. We have gone through thermoplastic now. Let us look at what is thermoset plastic. So thermoset plastic is a one more kind of a plastic where molecular chain of a thermoset polymers are characterized by a three-dimensional closely meshed cross-linking. So it is closely meshed cross-linking polymer which behaves in a particular way. This property means that they can no longer be shaped after hardening, or maybe we would have heard about exothermic reactions, vulcanizing. So once the hardening take place, it is unlikely that we can do some reactions or do some further processes and bring it back to the original stage. They cannot be melted. However, because of their strong cross-linking characteristic, so thermoset polymers, they are used widely for chemical resistance purposes, high level, and they demonstrate a high level of thermal stability, and they are brittle in nature. So the general terminology, most of the thermoset plastic is fiberglass reinforced plastic, so FRP, or people called even GRP. And some of the cases, if you go back, you can see these fuse covers and all, kind of ceramic type, the recent ones, not the ceramic ones, the recent one which are made out of thermoset plastics. So this is where the more broader level classification of plastics at a very top level. So the plastic, just to summarize, plastic can be further bifurcated into three main categories, that is elastomers, thermoset plastic, and thermoplastic. Elastomer, thermoset plastic, and thermoplastic. Like I said you that I will give you one household example to distinguish the characteristics of an thermoplastic and thermoset plastic. If you all of know, all of you know butter, which is used in most of the homes, and we know butter. So butter can be compared with thermoplastic, because when you melt the butter and pour it to the cavity, whatever the shape, so it takes that shape, and you can always remelt it and re-pour it to one more, and it takes the shape of that. So thermoplastic is like that, butter. When you cool it, it takes a shape, but you can melt them and reuse them as many times as you want. But thermoset plastic is, you can compare it to a dough prepared for making a bread. Once you prepare the dough and make the bread, you cannot go back to the dough stage. So even if you try to heat it, it will burn. It will not go back to its previous stage, unlike the butter. So butter you can compare like thermoplastic, and the dough or the bread you can compare to thermoset plastic. Let us understand more differences between thermoplastic and thermoset plastic from the view of way they are processed. So the thermoset plastic, certain polymers that the cross-linking together during the curing process to form a irreversible chemical bond. Irreversible. So you can note that in thermoset plastic, the linking is irreversible link. The cross-linking process eliminates the risk of product remelting when heat is applied, making thermoset an ideal for a high heat application. Yeah. So thermoset by process, during the process of polymerization, the curing process, what we call, or the exothermic cycle, what we call, during that process there is a cross-linking, the permanent cross-linking take place. Rather, you can call it as irreversible cross-linking process. Due to that, the end result of the material is so stable, it is mostly used for high heat applications. Thermoset plastic significantly improves the material mechanical properties. It also provides enhanced chemical resistance, heat resistance, and structural integrity. Thermoset plastics are often used for sealed product due to their resistance to deformations. So what are all the advantages of thermoset plastic? More resistant to high temperatures than the thermoplastic, high flexibility in terms of design creativity. You can manufacture these parts from very thin to thick sizes. Excellent acoustic appearances. Aesthetic appearance is great, and they provide excellent acousticness, that means soundproofing. And they also have a character of high level of dimensional stability, and kind of for a low volume viewpoint of view, they are cost effective as well. So let us look at what are all the challenges we have in thermoset plastic. So the main important one what we see is they cannot be recycled, and more difficult for a surface finish. You cannot achieve it is very difficult on the bare part of thermoset to achieve a high level of flat surface finish, and you cannot remold them or reshape them once the irreversible the reaction or the cross-linking take place. Let us look at thermoplastic in the same way, like the process, the features, advantages and challenges we have with this material. Thermoset plastic, thermoplastic, not thermoset, thermoplastic. Thermoplastic softens when it is heated, and it becomes more fluid-like character when you heat them. When you apply more additional heat, it becomes a fluid. The curing process is completely reversible. No chemical bonding take place. The characteristics allows thermoplastic to be remolded and recycled as many times as we want, without negatively impacting the material properties. So let us look at what are all the features. Thermoplastic is available in wide range of resins, and that offers various combinations of performance and applications. Most materials are commonly for not for high strength application, but shrink resistance and easy bondability, and depending upon the resin, thermoplastic can also serve as a low stress application, like the most common one what we see on day-to-day basis is the plastic bags. Those are all the one where we say low stress applications. And high stress, there are certain resins which provide some flexibility in thermoplastic to use them on high stress application like mechanical parts. We do see them nowadays, high strength plastics, self lubricating plastics like Delrin, polyamide. These are all the certain chemical names for the plastics which we use them in high stress application mechanical parts today. Let us look at what are all the advantages we have with thermoplastic. So the main advantage thermoplastic has is it is completely recyclable and highly recyclable. And aesthetically you can get a superior quality of surface finish, and with additives and a lot of resins offer high impact strength as well. And remolding and reshaping is always a possibility or possible in thermoplastic, so that's a great advantage. And they do provide a good level of or a high level of chemical resistance, and they have a character like hard crystalline rubbery surface kind of an option, which nowadays in high-end applications like in cars and the customized personal appearance of soft plastic, what we call them, where we get to see the like a touch and feel of a softness. And due to the fact that these plastics are recyclable, they are kind of an eco-friendly material or eco-friendly manufacturing material. So let us look at some of the challenges the thermoplastic has in comparison to thermoset. On the cost point of view, the thermoplastic is always costlier than the thermoset plastic, and they cannot be used for high heat application due to fact that when you heat them, they lose. They are not irreversible chemical bond. They have a tendency to melt it down when you apply a heat. That is a short overview of plastic. More view on thermoset and thermoplastic. I will give you one more video, next video, giving more explanation of thermoset plastic and different process possibility. How do we convert, how do we get an end product from a thermoset plastics? Thank you for watching the video and have a good time. Bye-bye.